Happy Wednesday there, ham experimenters. K8byp. I have successfully wound a 1 to approximately 2, actually 1 to about 2.2 transformer on a toroid to go from 50 ohms to about 100 and I figured 116 for my amplifier. It works. The first 3 that I wound did not work, and one was because of bad measurements. And my next transformer video will in detail describe transformer theory to you, correct theory, and the formulas and the processes needed to make this. It is highly unlikely that you'll grab a core and wire, even if you get a kit, and wind that and make that work. It gave me fits trying to do it. The point of this video is to show you the disaster that happens when you fall for the Balun Unan on a toroid thing with your end fed, off-center fed, whatever. It appears to work on transmit. I want to show you the train wreck that occurs on receive. Here's an RF generator with a string of attenuators on 5 megahertz. Just before putting the transformer in the system, it's the RF generator looking into the secondary of the transformer, which is designed to be about 116 ohms. So I've got the generator source set to about 115 ohms. And I've calculated and verified and done voltage measurements. The transformer is working correctly at 5 volts peak to peak. Now get that, 5 volts. I just did a quick table here of the voltage transforms from 2 volt peak to peak, 500 millivolts, 100 millivolts, and it tracks very, very closely. So close I can call it measurement error. Now, I took this generator and set it on 50 ohms at 1 millivolt peak to peak at 5 megahertz into the Kenwood 430 receiver, and I adjusted the generator to 1 millivolt, and I adjusted the adjustable attenuator to get an S5 reading on the Kenwood's S meter. Then I put the transformer in backwards, so the high resistance secondary is being driven by the generator at the correct resistance. 50 ohm output into the same attenuator, same adjustment to the same receiver. Now at 115 ohms, the minimum amplitude I can get out of the generator is 1.4 millivolt. So this time through the transformer, it's almost 50% more RF power. So that's 3 dB. Here's the ugly truth about these worse than worthless toroid Baluns and Ununs. On the same receiver, what was an S5 reading with 1 millivolt through the same attenuator setting directly to the receiver, now it's about an S3 3/4 through your wonderful Balun, and that's at almost 50% more power. The worthless Mickey Mouse blankety-blank and toroid Balun at extremely low signal levels has a tremendous loss. One S unit is, by the IARU, I think it's 6 dB, so that's half an S unit. So that would knock that down to about 3.3 S instead of 5. That's a lot of loss. And this is what leads our uneducated and uninformed people with their end feds and their off-center feds and their trash antennas and their Baluns and Ununs, because they fall for the myth from Jerry Sedgwick's book of these mythical currents on the shield causing radiation, blah, blah, blah. They don't understand that, yes, you can put a toroid transformer in line and transmit a significant enough power to light that core up. You will not propagate microvolt and millivolt levels through that giant core. And there's proof. And that's transmitting almost 1.4 millivolt worth of RF into the transformer. The losses will be even worse when you try to drive it with microvolts. And this leads these ignorant operators to to falsely believe that their antenna system's great because other people can hear them, but they can't hear other people, so they think that the other guy's antenna is no good, when it's entirely the fault of their piece of crap, fake multiband antenna, and their worthless toroid balun. You cannot use the same inductor, the same transformer, with this huge core that can handle many tens and hundreds of watts. You cannot use that with microvolt signal levels. It will not work. At such low signal levels, to put it crudely, the signal gets lost. It can't make enough field around those wires to couple into that core and back into the secondary. So about the only coupling is between the windings of stray capacitance, and stray capacitance is a gross mismatch. For a receiver or transmitter IF strip at milliwatts, tenths of a watt level, a couple volts, maybe half a volt to a couple volts RF voltage, this is the size of the transformer. That's an adjustable slug, and there's another ferrite slug inside it, the little fine 40 gauge wires wound around. Compare that to the BNC. See the difference? And this is an IF transformer for relatively high signals that have been amplified enough to get the signal above the IF noise level. It ought to be at least 40 dB over. For the front end RF circuits in the receiver off the antenna and maybe the first two RF amplifiers, they don't even use these little transformers. They tend to use inductors and capacitors in bandpass circuits. And that's what's in the front end of that Yaesu. Several bandpass networks to give fairly wide frequency spreads. And when that's done in the receiver, they're using tiny surface mount components. The scale of the RF power needs to be on par with the size of the components, because these very small energies are trying to excite these dielectrics in the capacitors and the magnetic fields in the inductors, and they're extremely tiny. It's like trying to use a match to boil a tablespoon of water. There's a tablespoon of water. A match can fairly quickly boil a metal tablespoonful of water. A match has no chance of boiling the water in a quart pot. That takes the cook stove, the cooktop, to do that. So on transmit at 10 watts, 50 watts, 100 watts, the transformer works. It's just a problem of the junk antenna that you've got doesn't match. You've got a bad mismatch, and I've proven that in my latest video on the antenna tuner myth. But you cannot pass the same antenna backwards on receive through that same transformer. It's got to be bypassed by a relay with an LC matching circuit. So reason number two, and an even larger reason why this trash Balun Unun on a toroid core and off-center fed you have is absolutely a worthless piece of junk. And this leads to antenna psychology. They think their antenna is great because others can hear them and they're using excess power, but they can't hear others. And you'll notice when these conditions are down like this, these people are not on the air. And the people on YouTube and on their ham sites that are bragging about their antennas, they're not on the air, because if they were, I would know them, because the whole world knows me. So there it is. Put this trash away, see my videos, make a real dipole, and learn what a real antenna is like. Then when conditions improve, you can go play with your junk fake multiband trash. So there's the scientific and engineering view, not the emotional view. Did it? And a correction, the additional 0.4 millivolts is not 3 dB. That's going from half millivolt to 1 millivolt would be 3 dB. That's twice. But going from 1 to 1.4 is not quite 3 dB. So call it 1 dB. That would make the S meter on the Kenwood maybe 3.5 S units. It's irrelevant. It doesn't work, no matter the excuses.